Okay. World's fastest human being. 9.58 seconds. He did it in Berlin. I think if you watch those previous videos, you saw some of his. I was an assistant track coach at Ruskin High School for one spring with Crazy Bob Neely was the head track coach, and I figured out real quick that it was a lot of hours, it was a lot of fun, but you didn't get paid much, and I could make much more being an adjunct math and science teacher over at Johnson County or at UMKC than I could being a track coach for a lot less, for like 4 times the money for about half the work. But anyway, it was the most frightening thing, the most horrifying relay of all, because you had your 4 best athletes on all the teams. Every team that was at the meet had their 4 best athletes on the track at one time, 8 of them. So there's 32 thoroughbreds out there on the track, and that's the 4x100 meter. That is the most nerve-wracking, the most horrifying, the most thrilling athletic thing I think that there could possibly be. I mean, you can compare it to the KU Oklahoma game of last year, where it went to 3 overtimes. I mean, that was exciting. That was sustained for a long time. That 4x100 only lasts like 40 seconds or less. It's amazing. But you just, please don't drop the baton. Please don't drop the baton. I mean, it was just nerve-wracking. But anyway, so let's calculate his kinetic energy on the run. Now, we've already calculated a little kinetic energy here. And then compare that to the Barabbas TKR, top speed of 270 miles per hour. The Bugatti that we're going to be looking at has a top speed of about 263 miles per hour, cruising speed of about, now this one is not street legal, I don't think. This is not street legal. This is like a Formula One type racing car. And it's very light. The Bugatti is 1,888 kilograms. This is only 1,230. That's a hell of an acceleration right there. What is the car when it's traveling at its top speed? All right, so we're going to look at some of those. So now this is the last slide, right? So one of the things I want to do with this slide, all right, is I'm going to write down some. Let's take a look at the Barabbas, and then I'm going to show you some of the stuff from the science and math of Usain Bolt too. All right, so we're gonna do a few things here. So it went from 0 to 60. I'm writing 60 seconds in 0 to 60 miles per hour in 1.67 seconds. So I'm going to calculate that acceleration, and it has a mass of 1,230 kilograms. So we're going to calculate its power. And we're also going to calculate its kinetic energy when it is going 60 miles an hour. So the KE at 60. So you're probably wondering, what is he scribbling on? And that's all we're going to look at for that slide for right now. And let's take a look at what I was doing here. All right, now, here's what I want you to do. I want you to pay attention. What we're going to do is we're going to find what is the acceleration of this car. What is the acceleration? And what do we mean by acceleration? Acceleration is how much it changes its speed over the amount of time. It technically in physics we'd say change in velocity over change in time. Okay, but we're going to say change in speed. But when you go around in a circle at a constant speed, you're actually accelerating because there's a acceleration going towards the center of the circle. All right, so first thing we got to do. So we got to take the change in speed divided by the change in time. So this would be 60 minus 0 divided by the change in time, which is 60 minus 0 over 1.67 seconds. Now this gives me an acceleration in miles per hour per second, because this is miles per hour. All right, so I'm going to belabor a point here and probably confuse you, and I don't mean to. 60 divided by 1.67 seconds, this gives me about 35.9 miles per hour per second. What that means, now this is more in tune with numbers that you're used to because you're all used to 40 miles per hour. That means every second it's gaining almost 36 miles an hour. Every second it's accelerating. Now, a car can't keep that up forever without throwing a rod or breaking down or something like it, because otherwise, within an hour, it'd be going the speed of light or something. I mean, it'd be going, you know, rocket speed. So let's take the 60 miles per hour and let's convert to meters per second. That's the first thing we've got to do. We've got a simple conversion, and I think we've done it already, where you just take 60 miles per hour, multiply by the 1609 meters in a mile, divided by meters per mile. So that gets rid of that mile. Per, leave the per in there, 3,600 seconds per hour. So that gets rid of that hour there. And 1609 divided by 3,600 equals 0.447. So that's just a quick and dirty 60 miles per hour times 0.447 equals 26.82 meters per second. So the actual acceleration of this car, A, is 26.82 meters per second minus 0 divided by 1.67 seconds. And this is amazing. I mean, this acceleration is just like that's like pulling 2 G's almost. 16.1 meters per second squared. That's almost 2 G's. That's like a rocket ship almost. All right, that's this killer. All right, so let's stop here, and because this is a good place to stop, and we will look at the Usain Bolt, some more calculations on this real quick, and then we'll look at the homework assignment.